And there are 8 different ways that we can go about factoring. And this number one thing, if you're going to write any note down, the number one thing you got to write down is, when I get stuck, look for a GCF. The greatest common factor is the most powerful thing in factoring. What do I mean? Look at that problem. That problem in itself is going to, look pretty ugly. But what is the greatest common factor between all of those things that I can have in this? Luis? Okay, not just a 2, but, you got to look at the x's also. 2x squared. This thing factors down to 5 plus 6x minus 12x cubed. Now, sometimes this will even factor out further, making it a 2-step equation. Right now, this is just a 1-step equation, factored out a GCF, and I'm done. Okay, by the time we're at the end, I'll have, put together all 7 things, and I'm going to put, all 7 of them in one problem. Okay? Yeah, that'll be the fun one. Okay? This is not a problem that you'd see on your test. Okay? This is the problem I put on my 4-term Algebra 2 class. Okay? Factor out a GCF. Okay? I don't know. You're more than welcome to join, but I don't think it would challenge you. Okay? You're not going to get as far in life, in that class as you would. Okay? And I would love to see you guys continue to challenge yourselves. Now this problem right over here, it is multiplying 2 common things together. This one you may want to take an example down, because it's a little bit different. Here's how it would look easy. What do they both have in common?
Y.
Oh, a y. Okay, that would be easy, right? There is a GCF here, though. But the GCF is not a monomial. It's a monomial. Monomial means 1. It is a common binomial. The binomial that they have, just like I did right up here, I basically came up here and didn't I divide 2x squared into each one of those terms? And that's how I got each one of those terms? Well, that's what I'm going to do here. I'm going to factor out, x plus 3. When I factor out an x plus 3, well, I factor out an x plus 3 out of this. What am I left with?
7x plus.
Okay, I'm left with 7x for this first one. And I factor out an x plus 3 out of this. And what am I left with my second one? 6. Do you guys see how these 2 things are here the same? Basically, what I was saying was y equals x plus 3. I basically substituted in here, instead of having x plus 3 here, I substituted a y in place of it, and then just factored it out. This, is factoring out a common binomial. Same thing as we did in example number 1. I factored out, a monomial. 2x squared. Here I factored out a binomial of x plus 2. Okay? Are we good to go on? Okay. I mean, I can split screen it here, but this one, you need to write down. Okay? Because if you see something like this, next chapter, I'm going to teach you how to factor all cubics, no matter if they're special ones or not. I have made this trinomial a special one because I've manipulated the numbers so it factors by using grouping very nicely. In other words, if I was to change this to a 23, it wouldn't work. If I change any of these numbers up here, it may not work. How we do this by grouping is we're going to take and group together these 2 problems right here. I told you what is the most powerful thing in factoring.
GCF.
The GCF. You are going to use that GCF every time that you do something, if possible. The GCF makes life easy. What is the GCF here of that first group? Now, the one thing I do have to tell you about grouping, you do have to put them in chronological descending order by their powers. If they are in descending order, the cube, the squared, okay, the linear term, and the constant, then you can group them. I'm going to factor out an x squared. And that leaves me with x minus 3. Does everybody agree with me? GCF, factored it out. I'm going to factor out what in this next one right here? Now we got just the 8, and what does that leave left? X minus 3. All right. Now, this is not my answer because I can now factor out a common binomial. I'm back to this step. Okay, right here. I factor out a common binomial here, x minus 3. Well, if I factor out an x minus 3 out of that, then that means divided here. That's left with x squared there. And I factor out an x minus 3 here, and that's left with 8 right there. Today, that's as far as you can go. Okay, in a couple days, this x squared plus 8 will factor further. But we'd have to learn what imaginary numbers are before we get to the x squared plus 8. Okay, because this factors, okay, using the quadratic formula, and the quadratic formula will tell you if it's a real answer or an imaginary answer. When I say imaginary, it's a not real. You know, if the real numbers are rational and irrational. Okay, if it's not real, they call it imaginary. Okay? All right. How are we doing here so far on a scale of 1 to 5? I know I'm going fairly quick. Not give you a lot of time to write, but I've gone through 4 examples so far. Yeah?
If you wrote down an imaginary number, wouldn't it be not imaginary anymore?
No, it's not pretend. It's, you know,
It's like
it's just not real. You know a real number, like the real numbers like an integer and things like that, they're called real numbers. They're not like, you're the English is, you're messing with it, and you're really messing up Sam. You're messed up. A real, okay, is not meaning pretend. It's a real number.
Yeah. What is a...
It's an imaginary number. Imaginary means not real. There we go. All right, you don't have to do this one because you know how to do this one. You should be able to do it forward and backwards. Okay, you should be able to do this one in your sleep. We did it all last year. The only thing I'm going to, again, stress is the shortcut. Okay, the shortcut here, 1 and 6. First thing you have to do with this thing is there a GCF to it? No. So, since there is not, should I even try 6 right here? Because if 6 went right here, that means there was a GCF of 6 that should have factored out of that. So that means I should have tried 6 here and 1 there, and whoa, that's way bigger than 1x. And the other thing I know is 2 and 3. 2. Can 2 go there?
No.
Okay, then maybe I should put 3 there.
No.
Okay, so I've just crossed off that example. Don't have to do that one. Okay, then I come down here in the 6 and 2. Can I put the 6 there?
No.
Okay, then I must put the 6 over here.
It's too big.
Okay, then I gotta put the 2 here. Or maybe the 3 there. Okay, so I've just crossed off that one. Didn't even try much. Okay, I come up here with the 1 and the 6. Can I put the 6 here?
No.
No. Can I put the 6 over here?
No.
I'm done with the 1 and 6 then. I'm down to my last possibility here, okay, of even trying to foil it together. And the 2, can I put the 2 there?
No.
Okay, because that doesn't work. So that means the 3 is going to have to go there. And then when we check this, we get 9x and negative 8x. And luckily, that comes up to be 1. Okay, that's factoring a trinomial. This, if you made it through advanced geometry, you need to be good at. Okay, we did that probably on an every other day basis. Okay, last year. Talked about this one quick yesterday, or on Friday. A squared minus b squared, where a and b are both perfect squares. They factor, okay, down to a minus b and a plus b. Is 4 a perfect square? Is 9 a perfect square? Now I do want to ask this question. What's the number in front of the x squared here? Is 1 a perfect square? Okay. This factors into x minus 5 times x plus 5. Okay, just like this one's going to factor to 2x and 2x, or a term is 2x. Down here it was just 1x. Okay, here we have minus 3 and plus 3. It doesn't matter which one's the plus and which one's the minus. The only thing that matters is, as you saw, because they were opposites of each other, those insides and outsides end up giving us 0 x's in the middle. Okay, I think that's 5 examples down, right? Okay. Number 6. Now, the only thing different between this one and the last one is this. Do the inside terms cancel each other out? They do not. This was my biggest, and Mr. Neff, I just laugh at him now because he's, saying wonderful things about why do they think this right here is that. You guys remember that big pet peeve that I had last year? You know how many times we did that? Because this right here, okay, is what you get for that right there. This is not the difference of two squares. Okay, this is, okay, a perfect, what we call trinomial, because it turns into a trinomial here instead. Okay, perfect meaning that right there is a perfect trinomial, meaning it's a perfect square, and so is 1 out here. I could put any number I want out here that's a perfect number. Okay, meaning a perfect square. Like 4 could go out here. This middle term will change. Okay, 16, 36, and then it ends up following this rule right here. Okay? All right. Just to recap, do you guys go ahead and write this down, and then I'll show you what I'm going to do here. Because I already did this one. I did it back in example 2. This factoring is called substitution. Because when you look at this right up here, you think, whoa, that looks kind of fancy. It's kind of like, and I'll come back to it here in a second. Some of you are going to freak out when I go to a different slide. This one right here. Okay. What did I end up doing right here? What did I factor out of this? A common binomial. Okay. I factored out a common binomial. Now this last one right over here doesn't have a binomial you can factor out of all of them. But you notice how I kind of explained this one right here? Notice how I substituted in y to explain the fact that I really just factored out y, and y was x plus 3? Well, that's what I'm going to do on this one. I'm going to say, well, let's just say, oh, I don't want, yeah, we'll use y. Well, let's say y is x plus 7. We're substituting in a different variable for this binomial. So basically, that's all I have to factor. Is y squared plus 5y minus 6 a hard thing to factor? Now, when you're done factoring it, you got to substitute back in the x plus 7. Okay, but, okay, go ahead and factor this. This right here, that shouldn't be too bad. I picked one that looks easy that ends up causing a lot of mistakes. Because everybody picks the factors of 2 and 3 because 2 plus 3 is 5.
I did 6 and 1.
You better do 6 and 1 because 2 plus 3 is 5, but you have to find multiples that give you negative 6. And to get negative 6, one has to be a positive and one has to be a negative. So I kind of was tricky. I'm sorry. Okay, I wanted you to realize that though that's your answer right there. I'm just asking you a factor right now. That's your answer. But one little minor thing. You see, y is really x plus 7. So I'm going to substitute in where that y is. I'm going to put back the x plus 7. Hold on, Rizwan. I'm going to answer your question here in a second. Okay, so where that y was, I substituted back in my x plus 7, and that finally gives me my 2 factors in terms of x, because that's what I wanted here. I wanted you to factor in terms of x. What is x plus 7 plus 6? X plus 13. And x plus 7 plus or minus 1 is x plus 6.
So that your answer.
That's your answer.
I'm going for
Well, I didn't ask you to solve. I'm just asking you to factor. So if I asked you to find the zeros, you'd end up having to set those equal to 0 and then solve to get negative 13 and negative 6. Okay? But right now, today is all about just factoring.
So when you do substitution, do you always have to state what y equals to?
You should always state what you're substituting in, and it's also helpful when you come back down to it that I got to remember to do that again. Okay? You can use whatever variable you want. Z, W. Okay. All right. So how are we doing here so far on a scale of 1 to 5? 5, I'm doing good. All right. Then let's put it all together. Yeah, 2 plus steps, meaning we got 7 different possibilities of factoring now. How many of them could I put in one problem? And I'm telling you, guys, on the tests and quizzes, I'm not going to put example number 1 on the test. If I wanted to do a GCF, I would put it in a problem where you have to do the GCF, then you have to do something else, and then you have to do something else. Because the 2 things you're going to see on your tests are applications and multi-step problems. You do. Okay, you are all supposed to be our pride and joy of Kennedy High School. And if only our pride and joy can add and subtract, we don't have a joy anymore. Okay? So, we have to be able to do more than this. Okay, and if I don't expect to challenge you here in class, okay, none of you would love just to add and subtract and be done with this class. Yeah, just ask me to add and subtract. I could do that back in 3rd grade. And that's what I tell you, somebody's going to have to become the doctors of our new world, and I do not want an idiot operating on me when I need one. Where do I cut? Who cares? How about right here? Okay, I hope someone intelligent knows how to do that. Otherwise, everybody in this world will become a doctor. I enjoy giving you guys a hard time. Nah, I do. I enjoy being here. It's just, well, the school part, I mean, I don't have to do the learning as much, but I love the psychology of trying to, reach out and get you to understand what I have here and manipulate, the situations. It is. It's not just me sometimes standing up here. It does sometimes. I'm doing very boring today, going through this, but I have to, use little strategies, and it's a challenge to become better at it. Because not all of you guys learn the same.
That is true.
So, how do I teach a mass with many different learning styles? Dance. There we go. See, I caught that learner. That's that visual type learner. They're seeing that dance. And then I see the audio learner. I just stand up here and talk today. With those hands on people, they like that dance.
Yeah.
I got the whiteboards I tried doing. Well, anyway, back to this. What is our first thing. GCF. You see something like this. Before you start crying, okay, you're going to want to find out GCF. There's a lot of power in it. And I think I see at least a 3x squared on that thing, right? Okay, so there's our first factor. Okay, that's going to give me x cubed minus 4x squared minus 9x plus 36. Done. All right. You're done. You're in my 4-term class. Okay, you're right. But you see this, and right now, there'll be a, the only way you know how to factor this is by grouping. Next chapter, you're going to learn this thing called synthetic division. And that factors every type of trinomial. I made sure this one comes out nice. Grouping. Let's group that part, and let's group that part together. All right, so our first factor still remains. Don't lose it. Okay, that 3x squared is still there. It is a factor. It will end up being one of the roots. The second one, though, is, okay, now that I've factored out by grouping, okay, I can see, oh yeah, there's a GCF here, this one of x squared. If I factor out an x squared out of that, that leaves me with x minus 4. And if grouping really works, when you factor out the next one, you better see an x minus 4 left over. And if it doesn't factor out an x minus 4 left over, that means grouping was not an option. Find one of the other ones that worked. Okay, and I'm looking here at this one right here, and I'm seeing, oh, if I got to get a minus 4 here, and this is positive 36, what should I probably factor out?
Negative 9.
And I factor out a negative 9. Well, that's nice, because if I factor out negative 9 out of negative 9x, I get positive x now. If I factor out negative 9 out of this, I do get negative 4. So in fact, when I'm done, and whether you use substitution here or if you want to factor out a binomial, okay, when you factor out a binomial, they both have an x minus 4. And what that leaves is the x squared minus the 9. So, what's that? The 3x squared is still a factor. Eventually, this is going to end up making, 5 different zeros. X-intercepts. Can't really say x-intercepts because sometimes the x-intercepts are imaginary. In this case, it does not. Okay, we end up getting 5, and you see this right here? What does that say right after that? How many steps have we done so far?
3.
Well, okay, we've done 2, maybe 3. Actually, there's one more.
Right.
And this is the difference between the A's and the B's.
Right.
Because this one right here is a difference, see, of 2 squares. 1 is a square, 9 is a square. Difference means subtract. This one factors to x plus 3, x minus 3. X minus 4. Okay, that's one of our factors, and 3x squared. I asked you to find all the zeros. You would then set all those equal to 0 and solve. Okay? 3x squared equals 0. Divide by 3, you get 0. Do the square root of 0, you get 0. Yeah. Alright? Alright, so on a scale of 1 to 5, where are we? The last one killed some of your fingers, I see. Okay? But I'm telling you right now, guys, when I hand back your quizzes and your tests, these are the things that you got to pay attention to. Okay? These are the ones that you got to ask me questions about as you're going through. Okay? Today's worksheet, okay, has, a breakdown of just each one of the steps, and then the back page, here you go. 2+ steps. I got a lot of those. Alright. I changed this instead of show me 11 and 66, since I accidentally added 27 and 40, what was the other one? 27 and 46 on there. What I basically want to do here is this. Step number 1 is test corrections. Okay, go ahead and get your test out. Alright, somebody came in before and after school and did all the checking. And everybody in here has taken the test? Who's run still? Here's my solution key. When we get back today, the rest of the period is a work day. Okay, the solution key is on your desk. I will get you your test right now. Okay, it'll be on your desk. Don't come back. Okay, let's get